Hello everyone. In this video, we will talk about the Emacs virtual machine. So I hope you have already installed the virtual machine. After you install and start the virtual machine, you would see a screen like this. So all the files for the Emacs framework are located in this folder in the desktop. So the first thing is how you can run it. So this is the main, let's say the bash script, which you can run, which will call all the dependent files. First, I will just show how you can run Emacs. So first, if you just open a terminal, then you need to go to this location, that's desktop Emacs. And then you can run the bash script, which is bash emacs.sh. So you see a screen like that. So here you have, let's say, 4 options. So mainly you can use the Emacs with VBots and Emacs with VREP. So let's first start with Emacs with VBots. You just enter option 1 and enter. So it will just compile if you made any changes, for instance, and if you are switching between Emacs and VREP, then sometimes it has to recompile. So the virtual machine has compiled now, and then you see more options. So you can see a simulate, open, and so on. So if you're just starting the, let's say the Emacs framework, first you need to open a scene. So we call it a scene. So here you have 2 options. You have a city straight and city straight night. So let's open a city straight scene. So you enter the option 2. So if you enter option 2, it will open a VBot scene like this, and it will take a bit of time, but just wait for it to finish. So once the scene is open, you would see, let's say, for city state, a console window like this, and this is, once you see this, this means that the scene has been opened. Then what you do is you go back to the original terminal. So there will be 2 terminals because one opened this VBots. So the terminal which opened VBots would be blank. So you don't close it, just keep it as it is. And then you go to the other terminal, and there you would see, let's say, enter option again. And here it says enter after the scene is opened. So just enter. And you need to choose a scenario. So we will discuss scenario later, but just enter, let's say, 1 for now. And then it opens a live plot. So that's there. And in this original terminal screen, you would see that the simulation has started. So the simulation might take some time, but here in this terminal, you see what's going on. So if there is some error or something, you would see it in this the initial terminal that you opened. So when you start and enters a scenario, there is another script, helper script that opens, which is a live plot. So basically live plot. So this is from a previous from my previous simulation, but then the live plot after some time you can see what is the current lateral deviation, steering angle, and what the images are. So it's more helpful for visualization basically. So what happens in VBots initially is that, so the car is starting from 0, from an initial 0 position. So it needs to gain speed. So in the current setting, we have designed controller for a set speed of 50 kilometer per hour. So the physics simulator tries to, let's say, model that. So you need to first wait for some time before the car can pick up that speed. So here you can see that the YL, or the initial lateral deviation, is set to 12 centimeters. Of course, you can increase it, but initially we just set to 12. And here you can see that the speed is gaining. So the car is gaining speed. And this is it's not the, let's say, the time for simulation, but this is the logical time. So this is the time that would actually happen when you run it in an actual system. So there are two time scales. There is a logical time and a simulation time. So you can see the simulation time is the time it's actually taking, and it's very slow. But then this is the logical time. So the logical time says that, yeah, it's only very less time. Like up to now, from the start of simulation, only 0.4 seconds. I mean, 0.4 seconds has passed. So this is the time that would happen if you run this on an actual car. So I have been running this for some time now. So now if you go to the main script, you can see that, so initially it was initializing cruising speed, and now the main VBots has started. So you basically see you capture image, you do sensing and processing, you do control computation, and then you do an actuation. And you can also visualize what's happening here. So initially it needed some 3.5 seconds to reach the set speed. And then after that, the controller started. So the controller sees that there is a deviation of around 12 centimeters. So it tries to bring it down to 0. And you could see the steering angle and also the image. So this is the output image with, which has the lanes overlaid. And this is the polyfit, which detects the lanes, and then from this image it computes the wire. And then this proceeds. So initially, if you're only testing your code, let's say for instance for compilation errors or something like that, then you do not need this long delay. You only need let's say some few initial steps, but I think you at least need like 5 or 10 steps, because the camera becomes active only after 3-4 steps. So you at least need that, and for that you can edit the main .vbots main file. So if you go to the Emacs folder, source src, there are two main files, one if you're using VBots, one if you're using VREP. So in this main file, there is a wait time or initial wait time. So currently I think it's set to 3.5. So for instance here, this wait time. So if you are only doing debugging, you can just set it to, let's say, for instance, 0.1, or because the step time is 5 millisecond currently. So the step time is hard coded to the WBT file. I will come to that. I will show you that next. But so initially, if you want to, let's say, you can reduce this 3.5 seconds. If you are only testing or debugging, you can set this to 0.1 or 0.25, something like that. So then it immediately starts testing your code. And once you are satisfied with the code that it's working correctly, then you need to, I mean, for the final simulation, you need to wait up to 3.5 seconds in VBots, just so that the vehicle reaches the speed. So I was talking about this world model. So so there is this VBot scene which we opened. So if you want to change the step time, let's say, so currently it's 5 milliseconds. So you need to open this WBT file, and you can search Control F step. So here you can see the basic time step was 5, so it's in millisecond. You can increase it or decrease it, but make sure that it's in multiples of your delay or sampling period, because if it is not, then you would end up in a mismatch. For instance, just to give a simple example, if I now have my delay to be like 8 milliseconds, but the simulator will only stop at 5, 10, 15, and so on. So the 8, you would have to round up to 10. So if you design for 8, then there would be a mismatch, and so on. So this was the, let's say, the VBots part. And yeah, so this, I mean, I'm just letting it run. We can see what happens. So now, for instance, so here I implemented LQR controller with delay less than or equal to sampling period. But for now you want to implement a new controller. Then what you need to do is the controller files are located as src lateral controller. So for the VBots, these are the two controllers I used. But if you want to write your own code, then you need to, I mean, I have commented the codes and also documented it. So you need to write your own matrices, functions, and so on. So the functions might be similar, but unless if you're using a pipeline controller or if you're using LQI or something else, then you might have to also edit this part of the code. So these two files you have to change if you are writing your own controller. And another important aspect you need to take care of is in the main.vbots file, there is this main loop. So this main capture loop, so the main loop for processing. So here there is the delay is just less than or equal to sampling period. So then your actuate steering angle is essentially just the previous steering angle, because this is a simulation. So when you capture the frame for that, so the logical time only progresses when you say it to progress. So here the actuate steering angle is the previous steering angle for this case. But now if you have a pipeline controller, then your P is not P minus, I mean, your U is not UK minus 1, but it would be UK minus P or something else. So then you need to also change this part. So essentially you need to understand how the timing progresses in this loop. And for your controller, you need to adapt that timing. But at the end, it boils down to just changing the actuate steering angle to, to point to the correct steering angle. So then you can, so these are then the main three files you would have to change if you are, if you want to add a new controller. So the steps are similar for VREP as well, but for VREP, there is currently no way to compute the actual lateral deviation. So here, this is the actual lateral deviation of the car from the center of the lane, not the look ahead one. So in VREP, currently that's not possible. So you would have to plot the YL at the look ahead distance. So VREP, so if your simulation is really, really slow, then I would suggest to use VREP, because VREP is a bit faster, and also the model used is a scaled down version. And yeah, so you might simulate faster. So here you can see that, so now it has reached 0. So this plot, it's because there are numerical precision issues, so it's the precision here is 1 centimeter. So that's why you might see a bit of irregularity, but it's yeah, it's just smoothed out actually. So this yeah, basically then this proceeds. So now it's already reached 0. Then once it reaches 0, then you don't have to, I mean, the controller is in steady state unless it finds a different yeah, the lane changes. So you would see that after some time there is a curve, but keep in mind that the LQR mainly you design for the regulation and not for tracking. And in this case, there is a dependency with lane detections. As you can see on the left, if there is a curve, it could happen that the right lane is not detected by your choice of region of interest. So there is a hard-coded region of interest. So for the scope, for currently, like If you want to do that, then there is a bit more tuning, and that's not, I mean, it's straightforward in the sense if you understand it, but it's not something you have to do initially. So we can just explore the possibilities just with this straight road. You can set a lateral deviation and then see how much time it takes to settle to 0. You could increase this lateral deviation or reduce it. And for that, to increase or reduce the lateral deviation, what you have to do is, I can show you that next. Okay, so here you can already see, okay, it's settling. So maybe now I am going to stop the simulation. So for that, don't close VBots because VBots itself takes a bit of time to load. So what you can do is you can reset the simulation. So you can reset simulation. So then goes back to your initial position. You can see it terminates your controller. And if you want to change your lateral deviation, you click on the car. Then you can see it chooses a BMW X5. And then you change this translation option. So you change this Z from 106,755. You can change this to, yeah, maybe if you change it to 8, you can see it moves a bit away and so on. So then if you want to test it for different, yeah, I mean, now it's not visible so much, but if I now, let's say, just to show that the car actually moves, set it to 110, just click on somewhere. You can see the car moved from here to here. So now I am closing it. I don't want to run this again. And basically that's the part of VBots. So this is more like a help script. So, and you can close this once it's done. You could also use that for say a plot. And now if you go back to the main screen, so since you closed VBots, the simulation automatically stopped, but that doesn't happen for VREP. In VREP, even if you close, you need to do control is set, but for VBots, the API is better. So let's say enter to continue, and then you go back to the main menu again. So here you see a bit more of options. You can now open new scene, or if some scene was already open, you could kill the scene, kill the VBot scene. Or if the scene was open and you reset the simulation, you can just simulate, you press 1. And if the live plot was not open, you can press 5 to open the live plot. You can make clean and recompile. This is only helpful when you are writing your own codes and checking. And you can quit to the main menu. Yeah, and then you can start with VREP. So I will just show for VREP as well, just once. So I use option 2. So it first compiles. Okay, now the compilation has completed. And so now you have some option to simulate with VREP scenes. So for VREP, I would suggest only use the straight road for now. So you use the open the scene 2. So you press R2 and enter. So it opens the VREP scene. So VREP is a bit more lightweight than VBots, and VBots works well if you have a graphics card and so on, but VREP doesn't need it. Also in VREP, we scaled down the model from, so the model, so the ratio here is 10:1, so 10 meters in the real world is 1 meter in this model, just to speed up the simulation. Otherwise the simulation takes a lot of time. So now, once you see this one, just say this road with cam like this. This means the scene has opened. And then once the scene is open, you can enter in the main terminal. You need to enter scenario, let's say 1. Then it opens the live plot again. And here in this, you can see it started simulation. It connected to remote API server, and it's waiting for 500 simulation steps. So it's the same with VBots, because you need to reach the required vehicle speed. Unless it reaches the speed, your controller performance cannot be validated. So it takes some time to reach that. And during that time, this car is just moving ahead. It's trying to gain speed. So it's the same similar steps as in VBots. And after some time, the controller will start acting. So yeah, that's straightforward. So I'm just closing it for now. So what was the scenario? So you see there is an option to enter scenario. And another thing is, so maybe for now, let's, yeah, first let's, yeah, we'll just keep it open. So scenario is basically something you decide or design for the controller. I mean, just so that, I mean, every time you don't have to change the controller you want. So for instance, in this lateral control VREP, I have mentioned there are a maximum scenario of 9. So that means I can have 9 values of periods and tau s. So there is 9. So the vector is size 9. And you could all, that means for each pair, let's say each pair of tau s period s, and there is a set of matrices present, like phi augmented, K matrix, gamma augmented, and the T matrix. So the T is a matrix for which keeps track of the controllability decomposition. I mean, you could also just design a controller without this. I mean, I have shown both. So in this one, it's using T, and for the VBots, you don't need a T, you only need the phi augmented K matrix and gamma matrix. So that's the scenario here. So for instance, if I now want to say, I want to simulate the case where your period is 40 millisecond and your tau s is 37.9 millisecond, I will choose scenario 0. If I want the next one, I choose scenario 1, and so on. So it's the same with the VBots as well. So if I go to this VBots HPP file, here I have defined 12 scenarios. And yeah, in the constructor, you can see there is a period of, there is a vector of size 12, and there are like phi augmented K and gamma augmented matrices. So this is a scenario. So most of the time, I mean, some of the time it takes to open the scenes. So normally what you can do is in VBots, you saw you could reset simulation. Similarly here, you can stop simulation here, and then you go back to the initial scene. And if you are doing that, then you can go to the main, yeah, as I mentioned in the VREP, even if you stop, you need to manually stop it. So you have to do a control Z. It's unfortunate, but because of the simulation. So you can do this bash. Yeah, I think maybe I can also show one more thing. So earlier I mentioned that, so initially instead of waiting for 500 steps, you could just wait for some time. So for instance, this is the VREP main file. So I say the wait time instead of 2.5, I can say, so here the simulation step is 0.005. So in VREP, it needs to wait at least 1 or 2 frames. So for this, I would just keep it 0.15. Then you can see how that happens. So you save it. So if you save it, then when you run the bash, you can see now. So I first open the bash, then I say I want to run it with Emacs with VREP. Then it needs to compile again because there was a change. Okay, it says compile. So now you see that the VREP is open and it's also the simulation has stopped. So you can choose option 1. So choose option 1. So earlier we started scenario 1. Let's say scenario, there were 8 scenarios. Let's choose 7. So just choose scenario 7. So it says, you can see it's initialized, waiting for 3 steps, and it's completed initialization. It's mainly because of the wait time. We set it to 3 times the simulation step. And now it would start your controller. So you can see here, simulation time 0, it does a capture, computes the lateral deviation, the steering angle, and then it delays 4, maybe the delay for 2, and then actuates. So there is a delay of 4 time steps, then it actuates. And then there is a delay of 0, maybe because when you round up with this time step, the delay is equal to period. Then it captures again at 20 milliseconds, and then this step repeats. So if we want to see what's happening, let's say, you can open the, and then the other thing is there is a documentation for this. So, so the location for the documentation is, I think it's hard-coded. I mean, it's put as a bookmark in the Firefox browser. So this is the location. You have Emacs doxygen output HTML index. So basically you just run the bash Emacs and then you have all the options here. So you can generate documentation using this option. You can choose to run with Emacs viewbots. Then you go to option 1. If there is no change in the code, there is make does nothing, and then you have these options. You can choose your options. So typically, if you are starting it, what you want to do is you choose the Emacs with VBots option 1, and then you open a scene. So for instance, you choose 2, and then just press enter. So it would automatically start the simulation from there. And then once you are done with the simulation, then it will come back to this menu. Then you can either decide to rerun the simulations. For instance, if you reset the scene, you can rerun the simulation. Or if you made changes to the code, you can make clean recompile. And or if you now want to simulate with VREP, you can now go back to the main menu and choose Max with VREP and so on. And this is just helper script that can help you do that. So if you have any questions, just write to me, and I will try to answer it as soon as possible. Thank you.